And top of the morning to ya. Got to turn down the microphone as usual. It resets to its normal level every time I power cycle the monitors. G'day everybody. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And good morning to everybody. Where am I? I am just getting into TTS, which is up and running, and it has a list. Sion is here at the top of the list. I don't know how it orders it. It's it uses the YouTube API to look at the chat and see who is in there, and I don't know. It doesn't matter. Good morning, Sion. Good morning to Michael Wise, Amanda Thompson, who once again has promoted the live stream on Facebook. Thank you very much, Crispian. And
outside the box said hello.
hello. Okay, I've got to turn that volume up a little bit. John Whips, Imi, Stephen W, Sharky, Tech Nebulous, Russell Rennie, Tabraze, Mlock, Tassie Bob.
Unexpected Maker said, I want to see a moving conveyor.
Hopefully we will see a spinning conveyor motor driver. Let's see, we have, no, not that one. This, we have some stuff here on the bench, including the little stepper driver for this. We've got this, which goes to the motor, which is here. This is the motor to turn the front conveyor. So I'm going to hook that up. And maybe we are going to get some stuff moving today, which would be really cool. DefPom, only here for a short time, but at least you're here. Okay, so better if the motor spins. Spinning driver might be problematic. Yeah. Let's not make the driver spin. Rand
Scott Miller
user
said,
list.
better if the motor spins. Spinning driver might be problematic.
Yep. Okay, so right up until half an hour before the stream, I was going backwards and forwards on what the subject would be today. Because during the week since the last stream, I have done stuff on both the PCB conveyor and also on the sorry, my voice sounds very crackly today. Again, as usual, always. I shouldn't comment on it because it's normal. And also on Testomatic. So I did make some progress during the week with Python, with a Python driver for the I2C interface on the AD5593R. Simon is here too. So good morning to Don S, DefPom, Jeff Lethbridge. G'day, Jeff. The Lane, Simon. Everyone sounds crackly this week. Yeah. But the thing is that I need both of these to be functional. It's kind of important for me in my day-to-day work. I need the conveyor for a few reasons, a few different applications. One of the reasons actually is that now that I have Sion's IN6 oven, one of the limitations of the IN6 is that the intake area is very small. Because the whole oven is designed to be as short as possible, the intake of the oven, where the little conveyor belt comes out, it's only about that long. So if you're going to be loading boards into it, by hand I mean, so ideally of course what you would do is have the oven at the end of a conveyor system. So you have boards go through pick and place, and then they typically would have manual inspection before they go into the oven, but there'll be a conveyor between the pick and place machine and the intake of the oven, so it's not a problem. Right now what we are doing is taking the boards out of the pick and place machine off the end of its conveyor, doing the manual part of it. Mitchell! Good morning, Mitchell, or good evening, or whatever it is. So what happens is that,
Dang, Mitchell is here. Don't balk TTS Mitchell.
yeah, so typically what we will do is take boards out of the conveyor on the end of the pick and place machine, lay them on the bench. So there might be, say, 6 or 8 panels or individual boards on the bench. Do all of the manual stuff that needs to be done, and then we'll have a batch of boards that need to be fed into the oven. And that means picking them up, walking over to the oven, putting them on the conveyor and letting them run through. Now with the old oven, the it's just running. Yeah, sorry, I was just reading something that Mitchell said. Hang on. Yeah, so with the old oven, the Bernie Boy 7000, it had a fairly long conveyor area on the input side. Oh, and good morning, Paul. Good morning to David Howes and to Paul. And so what would happen is that we could grab a couple of boards, walk over, put them on the conveyor, and you could queue a bunch of panels or boards on the conveyor on the input side of the oven. The IN6 only has that little bit on the front, which means you can put a board on there, and then you got to wait like a minute before you can put the next one down, because you have to wait for the board to very slowly proceed at like 120 millimeters a minute, or whatever the speed is that it proceeds through the oven. So yeah, it takes a while. And what I wanted to be able to do is have the conveyor that feeds them into the oven at an appropriate rate. So that is one application. Of course, I also need one on the intake side to feed boards that have been pasted, to feed them into the pick and place, and I need to join between the pick and place. So I've got a few 2 millimeters per second. Yeah, it's in that ballpark. The IN6 has configurable board ingestion, Paul. Yeah, the IN6 and all reflow ovens have a configurable rate on the conveyor, so that you can determine how much time they spend passing through the reflow process. And the rate on the IN6, depending on what profile you've set up, it's typically between 110 and like 135 millimeters per minute, if I'm remembering correctly. I think that's the way it works. No, it must be faster than that. I can't remember. Anyway, it's not fast. The conveyor is just very slowly moving. Already done it, Crispian. Oh, Imi. It was Imi. Sorry. Thanks for the reminder, Imi. I did that right at the start. Yes. So Sion is about to say something very important, which is it going to do it? Oh, okay. Here it comes. Generating.
Unexpected Maker said, well, you need an intake conveyor for the oven anyway, for times when your PNP is faster than your reflow process window.
Exactly. So it's all along, it's a queue, and there are different parts of the queue that move at different speeds and different bottlenecks, so the system has to be self-regulating and pass things along at the correct rate. So my point is, I need this conveyor project done, both for the project dopamine ticket off the list sort of thing, and also just for a practical day-to-day thing. And yes, Imi, I need more coffee too. I've had two.
Said, haha, shows how awake I am. The coffee is yet to come, lol.
Yeah, I had 2 coffees right before this. It should kick in soon. Then Testomatic, I also need to be functional. I have trays and trays full of boards in the cleanish room that are ready to be tested. I've got, I think, about 60 or 70 boards to be tested. These are for the water truck client, the water cannon related boards. And the test procedure on them is it is quite painful, to say the least, because the way I currently test them...
Outside the box said, Imi makes an amazing coffee.
Good to hear. And you can reap the benefits of that, Crispian. Oh, Alan, you're here as well. Good morning to Alan and Paul, I said hello to earlier. So it's the situation where, the classic thing, the classic process optimization problem. At what point do you stop grinding on doing the thing manually and put time into improving the process so that you are then more efficient? And I need to, I've been putting off testing these boards because I keep thinking I'm going to get the tester sorted and then I'll be able to just, spend 10 seconds testing each board instead of 5 minutes or whatever it takes now. And when you multiply it across a whole bunch of boards, I could be spending the next day, just sitting there testing those boards the manual way I do it now, which is connecting them to a water cannon and running a series of cycles on it, actually moving the cannon, hitting the limits, doing the calibration on the inputs from the hall sensors and the limits. That's done manually. So I want to automate it. Michael Wise says test in prod. And Stephen says it, use end users to test. Yeah. No, it's not totally over. I know you're joking, Sion. Sion says testing boards is totally overrated. Yeah. In this particular case, I need calibration. That is probably, I need both testing and also testing of the CAN bus communications as well. I need to be able to send commands over CAN bus and have the motor drivers act appropriately. That's on the Canon side. On the joystick end, I need to be able to simulate the joystick movement and read on the CAN bus what messages are being sent, so I can see. Oh yeah, Paul. XKCD, is it worth the time? Yeah, I was going to say that's a classic XKCD, but I think pretty much all of the XKCDs are classics. Is it worth the time? I'm going to pull this one up. XKCD, is it worth the time? I can't remember the numbers of things. Here we go. I can't remember the XKCD numbers. I know that there are people who just say XKCD 123 and then laugh because they know what it's referring to, but I don't remember that. This one is XKCD 1205. How long can you work on making a routine task more efficient before you're spending more time than you save across 5 years? What's the the alt text on this one is a long one. How much time you shave off? 1 second, and then how often do you do the task? 50 a day. Okay, let's say 5 per day. It's probably more than that, but if we imagine a test as being like a panel or a board, the scale would be somewhere in between these two, but I'm going to use 5 a day as the lower end. And how much can I shave off it? Say I can shave 5 minutes because I want to cut the tests from, this is roundabout numbers. If I want to, I'm going to cut the test from 5 minutes to like 10 seconds. So I'll just say that I'm going to save myself 5 minutes, and it's 5 a day, and that means it's going to be 25 minutes per day saved on average, and it shaves 4 weeks of time over a 5-year period. Okay, so that means over a 1-year period it would be about 4 days of time. I think. Anyway, so I can spend quite some days to save the time. Hang on. I need some dihydrogen monoxide. as opposed to dihydrogen dioxide, which would be a far less fun thing to ingest. Yeah, someone is wrong on the internet, Michael. Another classic XKCD. I used to fall for that trap, but I've given up. I just let people be stupid. Stephen says, shouldn't drink water, fish pee in it. They do. And so does everything else. So, what are we doing today? What are we doing? People are very good at being stupid, yeah. So what we are doing is looking at the conveyor. All right, here is my goal. First thing is to connect, all right, the very quick sequence. Here's the game plan for today. I'm going to switch to here. I'm going to connect, yeah, some of this is going to be reminding myself of what this design actually is as well, because I did this board design so long ago. I want to connect the Y-axis stepper, which is this. This is what runs the conveyor belt that, not the conveyor belt, the GT2 timing belt that moves the back rail backwards and forwards. So I want to make that stepper move. I want to connect the limit sensor. Oh yeah, so where are we? This is the stepper motor, and that plugs into this motor driver, which is just a cheapy ULN2003. So then we've got 4 step inputs and we've got power. So we want to connect that to this, and that connects on that header. Then I want to connect this, which is the limit sensor for the back, which is off camera view right now. When I home this conveyor, the front rail moves, the back rail moves backwards until it hits the stepper, hits the limit switch. That's how it knows that it's zeroed out, and then it's got a calibrated distance, so it knows where to move to set the conveyor to the correct width. So I want to connect that to this. Then I want to connect this. So this is the wire that goes down through the frame, comes out here, and will go to this. This wiring is all kind of weird and messy at the moment, but this is the motor that slides into the end here. The conveyor goes over it, the belt goes over that, and that's what makes things move along. So I want to be able to run this off this, which is there it is, it's the H-bridge motor driver. So I want to make that move. And we already have, last week before, I can't remember, we connected these time of flight sensors, so we know that these work. We can plug those in and we can detect distance, so we can use those to trigger based on the position of the board on the conveyor. And the short-term goal is, once I can home it, make the conveyor move, and detect the boards at the correct locations, I want to be able to put it into like a feed mode, essentially. Oh, and the other thing I want to do is have a look at the ready in, ready out stuff, which is not actually populated on this PCB at the moment. You can see that it's got positions here for read relays, and it's got in and out connectors here, which are the ready in, ready out connectors that go to the adjacent machines in the chain. So for example, if this was feeding into a pick and place machine, so it was on the input side of the machine, what it would be doing is looking for the ready in connection on the machine, so that when the machine asserts that signal, it says, yes, I'm ready for a new board. This can then start the conveyor and move the PCB onto the pick and place machine, onto its conveyor. And conversely, when it's on the output side of the machine, it will be asserting its own ready in to say when it can accept a board, and it'll be watching for the PCB conveyor, for the pick and place machine to assert its ready out, and when one is ready to send and the other is ready to receive, they both activate their conveyors and they run the board from one to the next. So as you can see, that isn't even populated. But for now, what I want to do, my first step, I'm not even going to use that, because what I'm going to do is put one of these in front of the reflow oven and set it so that what we can do is just queue up boards on the conveyor and then have it run on like a timed basis. So the Iron 6 reflow oven does not have ready in, ready out, because it doesn't have board sensors. It just it just accepts whatever comes in on the conveyor. So there's no communications required for that. It's just a simple timed system. So what I want to be able to do is, say, put a board on here, have the conveyor move it so that it comes up on the exit point. So it'll move up to this sensor right here. Where's a board? Okay, so we've got a little panel like this. It'll move along until it hits here, and then it will hold for some predetermined period of time. So I could configure it to be 1 minute or 2 minutes or whatever the feed rate interval is that I want on the boards. After that, it will turn itself back on and it will move the board off, and it will go onto the conveyor of the reflow oven. And it'll know when the board is cleared, because the sensor will tell it that, that the board has cleared the conveyor. And what it could do is then run until the next board comes up and brings it to the exit point. So there could be several boards in the queue here, and it can feed them on one at a time at a predetermined rate. And I can do that without needing any of the ready in, ready out sensors, because it's just time based. So, sequence of events for today. Oh, not doing well today. Sequence of events. Probably doesn't really matter that much, but I think for the sake of seeing this thing move, what we should do is connect the motor for driving the conveyor. So these are already tinned. Is my iron on? Yes, it is. And I'm going to solder these onto the other bit of wire. So the wiring for this is not as neat as it could be, and I've just got these little JST connectors on here for this. I need to figure out a proper wiring plan. So this is going to need to, yeah, I don't like this wire. I've got this little, it's basically single core shielded wire, and I'm using it as a motor driver wire. It's not the appropriate thing, but it was just what I happened to have handy at the time, so that's what I stuck on. Now, I am away from my computer and not watching chat at all. I have no idea what anyone has said since I moved over to the bench. So if anyone wants to get my attention, use TTS, and then maybe I will notice. I want a bit of heat shrink on this. Do I have any in my random offcuts thing? Looks like I don't. Oh, yeah, there's a little bit of heat shrink. There's one bit. Is there a bigger bit somewhere? Yeah, that's bigger, but it's too big. I might have to go for the real heat shrink container. And some of...
Cable tie said, never fear, cable tie.
Cable tie! Cable tie is here. I have not heard from you for a while, Cable tie. Alright, let's chuck this over. What am I going to do? I'll put the shield on the negative. The way I did this, I actually don't know which way the motor is going to spin. Like in terms of setting all of this up, I have not paid attention. Caffeine. What? Yeah, it's been a while. Yes, cable tie. Yes.
Cable tie said, "Yes, sorry, it's been a while."
Yes. Got a bit of heat shrink on there. Yeah, cable tie. I have not heard from you for a while, so I hope you're doing well. Hope you're doing well. That's right. So the I should have waited until it cooled down before I started moving that bit of heat shrink on, because it'll pre-shrink it before I get it over. Let's give it a go. Made it. Yes, that's right. So I was talking about the direction of the motor.
Bob said, "Of course you know which way it'll spin, the opposite of the way you want."
Exactly, Tassie. Whichever way I put it on, it's going to be wrong. Just like a USB connector. It has to be wrong the first time. But it doesn't actually matter as long as I'm consistent, because I can configure it in software. And what I've done is the two motor connections on here. So this is the back of the controller, and it's got, you can see, I don't know if you can read that, but it's got front and rear. So it's got these two JSTXH connectors, which are the connectors that go to the motor and to the motors, the front belt and the rear belt. And on the PCB, I've swapped the polarity of them. So one of them is in one orientation, the other one is in the opposite orientation, because the motors are facing in opposite directions. This one goes like this, and then the other one will be a mirror image. It'll be on the back of the frame like that. So they need to go in opposite directions.
Scott Miller said, "I've actually found a USB-C cable that can be backwards."
Oh, nice. Yeah, I think I've seen those before. They're kind of weird. Normally in a USB cable, you got the plastic tab that blocks off half of it, and I think the reversible ones don't have that, so you can put them in either way and they still work. And it's got contacts on both sides of the middle portion, but it's a mirror image, so you can just reverse it and it still fits. Yeah, pretty cool. Anyway, my point is, if I wire the motors the same, like positive to, say, positive to the left and negative to the right, positive to the left and negative to the right, because they're reversed, the motors will turn in opposite directions. So if they're facing each other, they will both turn in the same direction. That was a terrible explanation, but hopefully it made sense. And because I hate wiring JST connectors, I'm just going to wire it to a little 0.1 inch pitch thingamajigamy. And yes, does anybody here have tips for crimping small connectors?
It's supposed to be a charge only cable, only works one way. :
Oh, okay. I have talked over that message, so I'm not quite sure what you were trying to say. It's a charge only cable and it only works one way, but you can plug it in both ways. Is that what you were saying? I don't get it, but it doesn't matter. I don't get most things. I just kind of fudge my way along and try to figure it out. All right. Let's
Mitchell
get this on.
Tip for crimping small connectors. Get someone else to do it, haha.
Yeah. That's what I would like to do. The problem is custom cables are expensive, like really expensive. I need a convention on this for which is the positive and which is the negative. Even though it'll be inverted, I should mark it as like red and black, red and black. And even in the schematic, it is totally...
Scott Miller said, only has half the wires connected inside.
Oh, okay, so that's the USB cable you're talking about. Front. So I'm going to make positive, negative, as in red, black, which means I connect this one this way. I'm just wondering if while I'm here, I should wire connectors on. I am going to, yes. Otherwise, I'm going to regret it later.
Said, no, I don't mean buy. I literally mean get the lackey type someone else lol.
Get the what? Get someone else. Just for the fun of it, because they happen to be here, I'm going to use blue pin headers. I don't know why, but it makes it seem more festive. Oh, while I'm here, reminds me, in this, in the past you would have seen my pin header snapping blocks, these things, and then I just printed another one during the week because I needed to break off a whole lot of pin headers to a length of 4.
Where's Tom when you need him?
Yeah, the problem is that I don't like to inflict that nasty job on anybody else either, so I don't want to make him do it. And the blue ones are the pin snapping blocks that I'd made previously, and I didn't have one that did down to 4, so I modified the design and printed this snapping block so that I can, where's an example? Oh, there's a pin header. So with this, I can just chuck this in, go snap, and now I've got 4. And it makes it really quick and easy because you get the 40-way pin header, you feed it in, and you just go snap, push, snap, push, snap, push, and you can go click, 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 and just keep snapping off pin headers at the length that you want. And very quickly do dozens of them, which is very handy. So I'm going to be powering this up, and when I connect the, what am I connecting? Yeah, the motor. When I connect the motor to it, so I want to be able to then just keep running it without power cycling. So I'm going to stick this header in there.
Scott Miller said, train the squirrels to assemble cables. They'll work for peanuts.
I can't afford peanuts. Peanuts, a precious commodity. Come on, soldering iron, heat up. There we go. And now I'm going to burn myself by pushing on the pin while I heat it. Don't burn myself if I do it quick enough. Yeah, what else do I need to do here to be ready? To be ready, I am not going to get to the ready in, ready out connections today. I am fairly confident of that. The optocouplers are in place, but the connectors are not, and the relays are not. So I'm not going to bother with those right now. Ready in, ready out, that can be for a future problem. Kicking that can down the road to a future me. For now, let's get some of these basic peripherals working, such as, I want to see the motor spin. Let's make the motor spin. Oh, and while I'm here, let's figure out the connections. I think it might be back near the start. Go through my little lab notebook on this. Somewhere back here I've got the connections for, here we go, the limit switch, the on sensor. So I've got V plus signal and ground. I need to change this connector. So I do need to do a revision of this PCB. One reason is, if you look very carefully just down here, can you see it? slightly out of focus. Just down here, there is a bodge wire. And that is because I changed from running these motors at 5 volts to running at 12 volts. And these are just N20 gear motors. It's inside that 3D printed housing. You can get them in different voltages. It just, for whatever reason, my first version I was using 5 volt rated motors, and then I switched to 12 volt rated motors. I don't even remember why. It might have been some performance related thing. Something to do with getting the ratio correct. Oh, actually, I think it also may have been to do with power isolation, because the power that feeds into that little H bridge, which runs these motors, I wanted to have isolated on the input side of the voltage regulator that goes to everything else on the board, including the ESP32. I didn't want the motors running off the same 5 volt rail that feeds everything else. So by connecting it, so I cut the track to the 5 volt rail, and I put a little bodge wire on there that goes from the 12 volts in going to the H bridge. All right, so I need to revise the PCB for that. I also need to revise the PCB for the Y limit sensor because the pin ordering, hang on sensor. Oh yeah, that's right. So these are my notes from the connection on the sensor itself, which you can't see right now. No? Just straight up no? Okay. Then, so these are the connections. It's ground, signal, 3.3 volts. On here, I have no idea why I did this. Oh, actually, I think I did this because I was following the pinout used on servos. I don't know why, but I just did. With servos, what they do is they put the 3.3 volts in the middle, ground and signal on opposite ends. So if you plug a servo in backwards, it won't work, but you're not going to make any smoke come out. And I think I just followed that same logic where 3.3 volts is in the middle and then it's got ground and signal. But to match the connector that is on the actual sensor, it should be ground, signal, and then 3.3 volts. So what I have to do is make sure that I cross over 2 of these wires. Where are we? Yeah, I'll get to that. I'll plug this. I won't plug this in right now. First thing I want to do is just make the motor spin. That's it. Or do I? Yeah, yes. I just want to make the motor spin. So, because that seems like the simplest thing. The thing is that if I wanted to home this, if I want to test the limit sensor, I would need to also be driving the stepper, which means I need this wired up. We'll get to that. We will get to it. For now, let's just see some movement, and then at least we can consider this live stream to have been a success to some extent, for some definition of success. So I'm going to connect this to the front motor, other way around. I want positive that way. And then I'm going to need 12 volts into this because I'm running the motors at 12 volts. That means I need to change the settings on my lab power supply. I need to grab a cable.
Said DIY in the ghetto is in the house.
DIY, welcome. Thank you for coming along. Where did my cable go? Oh, there it is. I need my XT60 to pluggable screw terminal cable. That, and then I'm going to power this. Where am I going to power it? Either end, one of these connectors will do it. Is the polarity? Yes, it is correct. So positive, negative goes in there. Ooh, it powered up. I wasn't paying attention. I didn't realize that my lab supply was actually turned on. The output was turned on. There's a power switch here, so I can turn it off. Ba-chunk. All right. And what else do we need to do?
Said, I'm wondering who's taken John hostage. We seem to have made an inordinate amount of real progress on the stream today. Surely a squirrel in sight.
I know. I'm working hard. Cable tie. So
Jesse Bob said, is Alexa alive today?
yeah, but you failed to activate it. For some reason, it didn't pick you up. Which reminds me, March 28th, what is our plan, people, for when Amazon go full live audio streaming out of voice assistants and we can't leave them turned on in the room anymore? What is the plan going to be? There's got to be some alternative system that we can use. Okay, now I'm going to need some way of indicating whether this motor is turning visually. So I'm going to grab some blue tack and stick it on the motor so that we can see that turning.
The squirrels are on strike because John says he can't offer peanuts.
Yeah, I can't afford peanuts.
Said, March 28th is toss your Alexa in the bin day, isn't it?
It certainly is. March 28th, it's all over. The ride comes to an end. Now, I don't know if this USB thing is going to work. I'm going to change back over to here. Yeah, I pulled this up because we're going to get to this soon. This is the pinout for the stepper driver board. I'm going to... Alan says, just use... hang on. You need to be a mod to do that. Yeah, but I can do this. Just? Hang on. Why did it just say... interesting. I saw this happening last week, Mitchell.
Who needs squirrels? We've got electric motors.
Yeah.
Jimmy in the ghetto said, add a mute button for the microphone.
Yeah, Mitchell, I saw this last week, I think it was. If I click the little bell icon next to someone where they've been, where they've tried to do a say and it's been blocked because they're not a mod or a supporter, then it only says the first word. So I'm going to click on, where are we? Here we go. So this is on Alan's thing. I'm going to click it and this is what happens. Just. See, it only plays the first word. It was doing that last week as well. I would be going DIY voice systems and then have my home always on mute. Yep. This. Time to look at some code and see if we can talk to this thing and make it work. Make it move. Dentistries made a comment. Which was, where was it? Not been arranged, Mr. Did you get a new tattoo? Not new. Maybe 2 and a bit years ago. It's been a while. What's the say Q command? Okay. Cable tie. Say Q is say quiet, which means it says the message, but it doesn't announce who said it. It's just the message on its own.
Scott Miller said, AAAWWW. Now Mitchell is gonna mess with it, make it fail.
Yeah, maybe. Oh, that's right. What I'll do is I'll move that up there. And I need... I've just got to get to the right thing. Conveyor, PCB conveyor, firmware, and PCB conveyor 2. Here we go. Let's see if we can do something to make to make it spin. Can I zoom in? I can. Make the code nice and big. And bigger? Yes. All right. Now, what I want to be able to do is tell it to start moving. Do I have... Is there? No, I'm going to change it to a ESP32 dev module, I believe is what I need. Then port. Ooh, hang on. Did it come up? ESP32 dev module. Oh, that's a network port. No, that's not what I want. I think I may need to unplug it from there. This is going to be a little bit of a stretch. And plug it in directly to my computer. And then we'll see if the COM port appears. There it goes. Okay. So now we should be able to open a console. And whoop. And let's just see. Can we do anything? Oh, it's at 9600 baud. Why is it set to that? Oh, that's right, because I was talking to a washing machine. All right, now I'll try. Apparently it doesn't like that. Did I do anything? Where is the serial comms? Listen, is it that? Print back. It just sends it straight to the thing. MQTT comms, reconnect MQTT. No, I want G-code. So it does a parse G-code parameter. Home the device first, so it won't move. Do I have config of require homing? Limit back off, home switch offset. Somewhere. I'm pretty sure that I had a minimum conveyor position, maximum backlight. Somewhere. Okay, so here we've got the stepper control, limit sensor pin. Yep. Okay. I think it'll never, I don't think it'll move unless it's been homed. So this could be a slight problem. I've really got to remind myself of what's going on. Okay, but just for the fun of it, let's just do M03S blah. No, not that one. Where'd the console go? Oh, it's down here. M03S, I don't know, 800. Nothing happened. Although I thought I heard something. Which, yeah, for a second I thought maybe the, maybe, I'm just wondering how to get this on screen. I'm going to start my scope because it might be useful actually to chuck the, yeah, in fact that'd be a good way to do it. Let's see what happens if I, because what I can do is pull this up on screen, and then if I can make the H-bridge do stuff, we should be able to see it. Michael says, did you hear a capacitor fizzling? Yeah, I heard something. I heard something. I thought maybe I popped the H-bridge or something like that. Something did happen when I sent that command. Oh, hang on. What's going on here? What?
Scott Miller said, plot twist, pick the wrong motor. 12 volts smoked the 5 volts motor instantly.
No, it wouldn't actually. It would just make it run super fast for a little while. So what I don't know is whether, in fact, what I'm going to do is disconnect the motor. I just heard something else go click. Like, it sounded like a relay click. Oh, no, that was a relay inside the Rigol. What have I got it set to? I'm going to zoom out on the volt range, and then I'm going to pull up the web interface for it. Rigol web control. Rigol web control. So I'm going to move that down out of the way. I'm going to move that up there. And what are we set to at the moment? 200 milliseconds. What mode? Where's the... Yeah, doesn't really matter. I don't care that much. What are we at? 200 milliseconds, 500 kilosamples. It's not important. It's showing us something. Okay, now this, what I need to do is look in the code and see whether it is even trying. In fact, what might be a smarter thing to do is to bypass this firmware entirely and just load something that drives the H-bridge into a known state. So let's do M04S.
Mitchell R said, try the TTS bell button thing for me again. Just split on the wrong word.
Oh, it split on the wrong word. Okay, cool. Let's do that. I'm going to come back down to here. And I'm going to find... where is Alan's? I'm going to regenerate Alan's message. I think, if I can find it. Alright, I'm going to generate a different one of Alan's messages. Here we go. I've clicked the bell. It's generating the message.
Yes, voice on HAR works great. Just use a ESP32, maybe one from
Yes. And when it said one from that was one from which is Unexpected Maker. Yeah, cool. Thanks for fixing that, Mitchell. Now, what are we doing? What are we doing? Okay. Oh, hang on. What? Why was this taking so long? So conveyor setting to 900, conveyor write processing. Why did this take so long to suddenly appear? That is weird. There's some kind of debugging thing going on there. Okay, so I'm going to try M05, which I think was the stop command. Maybe... Oh, I'm looking at the wrong... I've got a different thing open on the other monitor. Okay, so M05, why does there need to be an S command for a stop? M05S, I'm just going to keep it at 900. I'm getting very intermittent stuff coming. Yeah, that's weird. Oh, these are from the limit sensor inputs. So why is it being so laggy and slow? Let's do a little bit of digging and see what it's actually doing. H-bridge motor control. Oh, select pins 4. That's already done. That is kind of done. Motors. Home X. I want to do set conveyor speed. G requested speed. Set conveyor motor speed. So that's stop, left. Was I out of range maybe? What are the acceptable ranges? 600 to 2200 millimeters per minute. I don't even know if I'm enforcing that. Am I? Aren't I? G-code. Okay, let's find out. G-code move. Spindle stop. Spindle right. So we've got direction is right, requested speed, and set the speed. So where is set requested speed? Where is set requested speed? Somewhere. There. No, not there. Oh, get lost. Set requested speed. void. Alright, so it is checking if it is greater than the minimum speed and it's less than the maximum speed. Or it's 0. So you can set it to 0 or any of those. Requested speed. Yep. Okay, so that seems to be working anyway. So setting it to a speed of 900 should be okay. Where was that config? So minimum speed 600 to 2200. Now, where? Where is the, oh, pin X, pin Y. I guess I should check those, shouldn't I? Motor PWM frequency. Where is that being driven? Set conveyor speed. Set requested speed. So we're doing, if left is the X direction, we're writing there, serial print line, G requested speed, setting write speed to, let's push this to it just so that we can see what's going on. Yeah, I am still following a bit of a random chaotic process right now. I need to stop and think about what it is that I'm trying to achieve. Okay, what I want to do is make the H-bridge run. So let's make sure that that I'm doing that. Michael says, whoa, there's a process to this. Apparently not. X-axis motor. Okay, so this is the DRV8871, which is the H-bridge. And this is where you can see that I've swapped. So pin 1 goes to out 1 on that, and pin 2 goes to out 1 on that. So the two connectors, the front and rear connectors, have swapped polarities. They're both coming off the outputs of the H-bridge. Then we've got IO 32 and 33. We're just pulling I limit low with a 15k resistor to disable the current limit on the motor driver. Or is that an output? I can't remember. In any case, I don't care. So, back to here. Config 32, 33. Alright, so we've got the pins set. We have the motor PWM frequency set. Did it take that long just to compile? It's still uploading. I clicked that ages ago. In that time I opened that project in Fusion. Let's have a look at what happens on the console. Okay, clear that. Let's go M05S900 and we get no acknowledgement. There is definitely something weird going on with this. Serial comms, listening to the serial stream. If debug serial print received character. Okay, do that. Yeah, we've got new line set on the terminal. Yeah. Oh, hang on. Failed to initial. Oh, it's taking ages because it's trying to initialize those sensors. Let's plug the sensors in and see if that makes a difference. So I have a feeling that the controller must just be taking ages to do anything because it's, yeah, it's trying to do something that is not going to ever work. Left, left, right, left. So left, is, which one's this one? That one must be the middle sensor, and this is the right sensor. Doesn't quite reach, so close. Okay, so we've got sensors plugged in now. Ooh, and now we're getting different stuff going on here. Okay, let's close that. I'll clear it, and I'm going to do M5S800. No, that was M5 was stop. M3S800. And we're not getting any acknowledgement. Okay, I'm going to try, what am I going to do? Reset. Where's the reset button? Is there, no, I should have put a reset button on the carrier PCB, because the reset button on that display module is, it's covered. So the way around that is, let's just upload the firmware again. That'll force a reboot. And while it's doing that, set requested speed, conveyor left. So it should be doing it should be connecting to MQTT as well, but okay. I think that what I'm going to do is bypass all of this complexity and just do a really simple program that does nothing but try to make the H-bridge move just by setting the 2 pins. Maybe make it go different directions. That is if this fails to work, which I'm pretty confident it will, because I haven't changed anything. Okay, so it's now reporting the sensors. Why isn't it reporting the first sensor? Yeah, so if I now move my hands over the limit sensors, oh, there we go, it's reporting sensor 1. But sensor 1 had the condition where it was not reporting unless there was a value or something. So you can see I've got my hand right over it now. It's down in the 20-something millimeter region. I'll lift my hand up and the number on sensor 1 goes up. So sensor 1 is the input side, that's the left side sensor. And then I can put my hand over the other sensors and you'll see the numbers change as well. Okay, so maybe it was just hanging up on sensors. Let's get rid of... Let's get rid of all that debugging. So if sensor range status, yeah, let's just yoink these out. And yes, I should define a sensor debug. Yeah, a sensor debug config or something, so I can turn that feature on and off, get it to dump out the values or not dump them. Dentistry says sensor 1 seems to be putting on a different line. Yeah, they're all on different lines and they're just indented different amounts so that you can distinguish them in columns. But there was something different about sensor 1. What was it? Sensor 1, why was it only printing when, so if it's not equal to 4, yeah, I don't know, maybe it was something, no, I don't know why sensor 1 wasn't printing. Yeah, very crude debugging. It was just indented by different amounts for lines 1, 2 and 3. Okay, so it's connected to MQTT. Let's give it the old M03 S900 treatment. Setting to 900, conveyor left 900. Okay, what about M04 S900? Setting to 900 conveyor. Did that say conveyor left again? Let's check that. Requested. Setting right speed to...
Scott Miller said, look where the 3 sensors are pointing.
Yeah, there's probably stuff. But all I wanted to do was get past the point where the sensors were stopping the initialization. Setting to requested speed, GX requested speed. Why was I doing that? Setting global. Okay, I'm not going to break my brain by trying to reinterpret what I was thinking back then. Set requested speed. So we've got, oh, I see. Oh no, I don't. Let's go back to G code. Okay. Conveyor left, conveyor right. So if it's M code spindle right, it should go right, conveyor left. And the codes are 3 is moving right to left, 4 is moving left to right. That's written in a really confusing way, isn't it? Now that I'm going to upload this while I'm looking at that. Because it's just spitting out that in the loop, which I don't want to do. I want to be able to see it responding to the left and right commands. Now the motor right now is disconnected. So let's see if we can find what, oh, excuse me. Oh, look at
Pete
this.
said, coffee o'clock.
Look at this. Something is actually happening. Because the motor isn't plugged in, when I sent that command, I just assumed that it wasn't working, but maybe it was. So it's now flatlined because it's doing the reset, MQTT connection. Let's move this over here so we can see the terminal and the scope output at the same time. And I'm going to go M03S900. And now it is doing a thing. It's kind of weird. I'm just going to zoom in on the scope. It's doing like a PWM thing. That's kind of strange. That's very strange. That is not the pattern that I would expect to be seeing on the scope. So if we change that, instead of M03900, I'm going to change it to M04900, which moves in the opposite direction. We should see it flip to the top. There we go. So the motor is now being driven in a forward direction. If positive is positive and negative is negative. Michael says 404 motor not found. Okay, so what happens if I now change this to be 600 and the duty cycle changes? What's interesting is that it's not going to 0. It's never actually turning off the motor. What happens if I do a speed of 0? Yeah, then it flatlines. But I don't understand why. If I do say a speed of 900 millimeters a minute, why is that square wave not going down to 0? That is super odd. Hang on, I'm going to just drag the trigger, drag it up there. I love the fact that I can control the scope through the browser here. I can just click on stuff and do things. Alright, so that is now, yeah, it is now PWMing. So if I take it up to say 2000 millimeters a minute, you can see that it has changed. It is not at all though what I expected in terms of the duty cycle, like either the duty cycle or going to 0. It shouldn't be going between like 6 volts and 12 volts, which is what it's currently doing. Very, very weird. Let's change that back to 600 millimeters a minute. Yeah, well, we got something. if I plug the motor in, maybe it'll work. Let's find out. I'm going to plug the motor in. Okay, motor. Blue tack it down, make it stable, and I've set the speed to 0. But now I'm going to set the speed because it isn't loaded. Oh, that is a very good point, Crispian. All right, you can't see me now. I'm off screen, but I'm going to go one direction. Ah, we have, yes, it's a very noisy signal. That is running way too fast. Let's, maybe it is a 5-volt motor. I should pull it out and find out.
Scott Miller said, is there capacitance on the lines to the scope motor?
No, there aren't. Ooh, that's interesting. I increased the speed and the motor slowed down. What happens if I make it 2,200 millimeters a minute? Then it goes super fast. What if I make it 2,000, 1,800?
Pete said, your face is a noisy signal.
It is a noisy signal, Pete. 1,500 and 1,200. At that point, something weird happens. What about 1,300? No. Oh, and then it just starts. So there's definitely some calibration that needs to be done on the motor. In fact, if I set it to 700, let's see what happens. Then it goes faster. Yeah, weirdness happening on the motor. Oh, and then it goes faster if I go to 900. I'm going to take it up to 1,300. And then it runs slower again. 1,400 millimeters a minute. And check this out. Look at what's going on the scope. It's jitterbugging all over the place. So yes, it needs a capacitor or something across it. I could put just a little one, like, I don't know, 22 picofarad or something. Haunted motor.
Scott Miller said, haunted motor.
Yeah. All right, so we have conveyor movement. I'm going to set the, actually what I'm going to do is do an M05, which is a stop command. And then it stops. Okay. Pete says, my life could do with a capacitor across it. Yeah. Yes. So we've got, yeah, conveyor stop. The number that it's reporting here is the M code value command, and then what it's doing and the action.
Outside the box said,
This is what it's processing.
bias.
Wrong DC bias. Yeah. Yes, which is odd. So let's have a look at the motor driver. So we've got in1 and in2. And what we should be able to do is drive one high, one low. And what are we doing in the code? Now, move and move that back to there. So what are we doing in the code? Motors, home, Y, set speed. So we're doing an LED C right, and we are setting channel 0 to 0, channel 1 to the requested speed. But what is the requested speed? I think my suspicion is that way back when I was working on this code, I did 0 calibration, as in whatever number comes in here really means nothing. Like if I go into the console and I send it a command of this S1400, in theory, that speed, that 1400, that should be 1400 millimeters per minute. But there is absolutely nothing in this code that does anything with that number except pass it to the LED see write function. And I think that was one of those future things. Once I had the mechanicals up and running and I could run it and time how long it actually takes to travel a certain distance, then, oh, look at this. There's even a note from past me. Calculate motor PWM value here from requested speed. Perhaps use a map function. Yeah, how about that? We could do a map function. Yep. Oh, comment from Dentistries. Okay, so Dentistries asked, you may have mentioned this at the start, and I know it was spoken about a while ago, but what is the current state of the cleanish room and the final plan, including the conveyor, etc.? Yeah, and DefPom says, is it a value overflow causing the odd speeds? That, yeah, this, yeah, something needs to be done in here. In fact, let's do this. Do stuff here to fix motor speed. Yeah. Do it. Do it. So the at the moment what's happening is whatever value I am sending through in that G-code command, technically an M-code command, is simply coming in here, GX requested speed. So we've got, where are we, G-code, okay, spindle right, we've got extract the requested speed, so we've got parse parameter on the S value, which is the speed value, and then we call set requested
Scott Miller
speed.
said, try giving it PWM values instead of speeds.
Yeah. What'll happen is that if the PWM value is outside that 600 to 2200 range, it won't accept it because it's got a filter on it. Now, I'm not going to fix this problem right now. I want to keep making progress on other things on the stream because that can be fixed later now that we've identified this. So we've got what was I looking for? That's right, Dentistry's had a question about what's the state of the clean room. Cleanish room, I should say. Now, I can show you what it looks like. Where is, I'm just going to bring up that and that. This is a live view from in there at the moment, so I shall use Shuhu I shall not be using after March 28th, which is Alexa, turn on the cleanish room.
Okay.
Boom! And it totally blew out the thing. So yeah, Dentistries, I don't think I have seen you here in the chat for a while. Current state of the cleanish room. 2 pick and place machines are now on these big steel stands with leveling casters. And right now the Bernie Boy 7000 that you can see there right in the front of the picture is all connected, but it is not currently being used because just behind it, look what you can see here. See, just in tiny little text it says Neoden. This is Xeon/Unexpected Maker's IN6 reflow oven, and you can see a big orange 15 amp power cord running across the floor there going to it, because I am currently borrowing / stealing / hopefully buying Xeon's IN6. So the current state of the cleanish room is that it's in pretty decent shape, it's nice and clean. 2 pick and place machines up on stands. You can see the keyboards. Yeah, there are acrylic keyboard mouse stands here. They've got monitors up on adjustable arms. And on the right, you can see down here, You can see boards in trays. Up here you can see boards in trays. What you can't see is behind this duct right in the middle of the picture, on this shelf, there are rows of trays back there with more boards obscured by this, and those are boards that need to be tested. And then up here you can see this is something I just did late in the week after visiting Sion's and seeing how his PCB storage was done. I went to Spotlight and bought some airtight food storage containers. So there are storage containers up here now, right in the middle of the picture, with PCBs in them, and I've separated them out by client and project and things. So I've got parts, all the parts on reels are stored in these airtight plastic containers up the top there. Each one of these containers has a bunch of desiccant in it, and also a temperature humidity sensor that's visible through the front. So you can see the little black thing, that's a temperature and humidity sensor. It also has a Zigbee Akara temperature and humidity sensor in it, which is transmitting, and so what I can do is pull this up. This is the live feed from inside those containers. So we can see, for example, parts capacitors is currently at 20.8 degrees and 40% humidity. I need to refresh the desiccant in some of these containers because this humidity is starting to rise. You can see the lab environment is currently at 56%, but the humidity inside those boxes is lower. Resistors 2 is at 35%, part semiconductors is at 34%. Ignore the printer 1 Enviro 654, that sensor is not even running. So the parts are stored in those sealed containers with reporting of their environment. The PCBs are stored in these sealed containers. No reporting, but they're just in sealed boxes now. So that's the current state of the cleanish room. Yeah, so Dentistry said, that looks so much more organised than when I last saw it. Oh, thank you. Yeah, I've been working very hard at making the process run smoothly. So the rest of the comment was, looks great. As part of your consultant work, are you also producing boards for your clients?
Scott Miller said, you need to feed those values to an influx Grafana server, make NR dashboard with charts.
Yes, I do. So at the moment they are being published to MQTT, and I could add them to Grafana. Done stuff here for the motor speed. Light explosion. Yeah, so dentistries, to answer your questions, yes. That is one of the reasons that that I've gone to so much trouble with setting up the cleanish room and improving it to make it all streamlined. The rate of board production has increased significantly in the last 6 months for my clients, for contracting clients, consulting clients. So I do the design work, and then far more of them now are wanting to have me produce boards rather than have the board production go elsewhere. So I have my son working full time doing board assembly, and over the last couple of weeks I've had my daughter here working as well. She has been one thing you could not see in that view. In fact, I wonder if I've got a picture that I can show you.
And then display the dash on one of the clean room overhead monitors.
Yeah, exactly. That's what I want to do. I want to have a lot more data displayed up there. I'll just see if I've got a recent picture of the cleanish room facing in the opposite direction. This was the start of me organising the PCBs during the week. So this was when I just bought the first 8 containers, and then I discovered I needed more, so I added more containers on the end. That was the start of PCB organisation. Other things I've done, I'll get back to the conveyor in just a second, but other things I've done are I welded up a a frame for a workbench. So that's the steel frame, and then I put a, whoop, where are we? I then painted it, so that is the painted version of the frame, and then I chucked a bench top on it. So that is the that is one of the workbenches. This is going in the mechanical area. That was just when I was putting the bench top on it. It's a 2400 by 600 kitchen bench top, and I'm going to make 2 more of those benches. Then, where are we? Got to find. Just trying to find a picture that shows the far corner of the room. Well, there's this one. I was taking this picture to show the difference between the IM6 and the Bernie Boy.
Said, what module are you using for humidity tracking that reports to MQTT? Is a BME 280 good enough?
A BME 280 is good enough. That's not what I'm using in that particular case. I'm using Zigbee Akara sensors, which are connected to a Zigbee to MQTT gateway on a board that I made. So Zigbee, where are we? Superhouse. Let's see if I can find it. I don't even know where it is. Products, Zigbee. Where are we? Where are we? Displays, sensors, modules, sensors, Z-Wave. Nope. Oh, I think it's one of those things where I've made it and never actually put it up for sale. But it's an ESP8266 based thing. Zigbee. Let's see if I can find it. Oh, here we go. This thing. Is this it? D1 Mini Zigbee Shield. No, that's not it. It was this thing. When was the last update? 5 years ago. Yeah, so this has got a Wemos D1 Mini on it, and then a Zigbee module goes on there. It runs the, yeah, anyway, not that interesting. It just allows you to act as a coordinator for Zigbee devices and then publish to MQTT. Oh, Fazla, is that how you pronounce it? I'm watching you live from Bangladesh. Welcome. So, all right, I got to get back to this. Where are we at? Oh, that's right. No, I was showing dentistries. Just scrolling back through photos here. I've got to do this off screen. Do I have a view? Oh, here's an in progress view. So the back left corner of the room, this is when I was just starting to set it up. So this is the desk that I was setting up in the corner. It's been raised and there's fume extraction, soldering iron. Now it looks much more developed than this. It's now got soldering iron, like a tip cleaner. It's got one of the new Aishun soldering irons, and there's an overhead magnifier and all sorts of stuff there. So that is where my daughter has been working, assembling boards in the chip mines, slaving away. Can you see it in here? No. Here? No. Anyway, I'm just looking for photos. Yeah, you can kind of see it in this view. So this is looking through the glass from the front of the room, and down in that back left corner now is another workstation area with all the gear. It's all set up now, so it's a nice place to work. Helen says, and I'm watching you live from bed. Sounds like a great place to be. Now, let's get back to this. So far, all we've done is made the motor spin, and I need to fix the motor speed. All right, let's see it go through a homing sequence. that is what I would like to do next. Because there are a couple of things that could be done from here. Let's see, there's half an hour. I could hook up the stepper motor driver and the limit sensor, the y-axis limit sensor, and tell it to do a homing sequence. That's one thing. The other thing is, and this is going to be somewhat more complicated, tell it to move until it detects a board at the exit of the conveyor and then stop. But that's going to mean setting up a state machine and a whole bunch of other things. So that's kind of that is kind of major structural stuff. Okay, so in this firmware, I need to do a couple of things. First thing is I need to make all of the individual peripherals, etc. work. And then do the higher level orchestration. At the moment, what's happening is that we've got control of the motor, which is working even though it's uncalibrated and the speeds seem to be bizarre. So whatever value I'm setting here, the requested speed value, is being passed through directly as GX requested speed, and it is doing a PWM write using the LEDC driver, and that number does not necessarily make any sense whatsoever. So that's got to be fixed. But at least we can now control the H-bridge. That's good. We know that the PCB sensors are working because we saw that happening earlier in the stream when it was outputting the range values, which means what I can do is set a threshold. So one of the things I'm going to need to do here is, in fact, I will do that now. Any distance less than, say, 30 millimeters. This is all going to y-axis limit sensor, PCB sensors. Let's define this here, even though we're not using it yet. PCB trigger height, and let's just make it say 30 millimeters. Anything detected less than this means a PCB is present at the sensor. Hopefully that is self-explanatory enough. Go forward until it crosses the middle sensor, time it until the entry sensor trips, saying no board over it, and then reverse for half that time. The board will be centered in the conveyor now, says Jack's Tech. Yeah, okay, that is good logic. So that would work. That'd be a good calibration sort of thing. Yeah, where was I? Config. All right, so PCB trigger height. I think what we were saying, yeah, this value needs to be changed. I could just measure it. Since I have plenty of rulers here, I could measure from there to there is about 20 something millimeters. Yeah, anything below 30, I can make it 35 just to be on the safe side, but it doesn't really matter. If something comes across here, it's going to be reading something in the 20 millimeter region. Yeah, let's change that to 35. This is all open to tuning anyway. So 35 millimeters.
Outside the box said, unless there is a differing amount of drag in alternate directions.
Yeah, Crispian is correct. It could be running different speeds in different directions, but it'll be close enough. Close enough for government work. Yeah, so at the very highest level, 3 classes of things that we need to do. Let's make some notes in here. 1, make all the peripherals work. And that is going to include That is going to include speed control of y-axis, which is the motor, the DC motors. I also need to standardize. This is the other thing, is the motor that is in it right now, I don't even know if it's the right motor. My calculations were being done based on, if I come back to my little lab notebook from here, is it forwards or backwards? Here. So my calculations were being done based on the radius of the drive thing, which is this thing right here, and the speed of rotation, so the RPM required to get a linear movement at a speed that is within the right sort of range. So RPM, so I want anything from 44, hang on, what is that? RPM is 10,800, gives, divided by 50.265 is 215 RPM. Yeah, however I was working this out. What I worked out is that I need a 120 RPM motor. So 120 to 180 RPM at 12 volts, somewhere in that range. And that'll give me the speed range that I want on the conveyor. So what I need is a 120 RPM 12 volt motor. I don't know if that is a 120 RPM 12 volt motor. I need to open it up and have a look. And a lot of the time they're not even marked, so you can't tell. I need to make sure that I have the correct motors in there. So that's step one. So speed control of y-axis motor. I need to PCB sensors. To do, let's get a little bit of organization in this, PCB sensors. So it's a sub to do, inner to do. So we've got one, make all the peripherals work. Okay, let's do the top-down design approach here. Make all the peripherals work is step one. Step two is going to be direct control of operations, and that is not taking into account any sensors or anything like that. It is just telling it to move or do something, and that is going to include move, home, move left or right, and oops, what else do we want it to do? Report sensors? I don't know, maybe not. So direct control of operations, we want to do, oh, that's already done. So to do, and done. So we can move, in the G code, we've already got commands for, in fact, let's see what we've got. We have homing, go to a certain distance, speed, and stop. Okay, so set conveyor width is the other one. So to do, done, home, set width, and move left and right, and stop. Okay, so we can directly send it commands to do those things. At least I've had those working on the previous prototype, so we need to revalidate that. Then, let's move that here. I like to have a plan. It makes me feel like I know what's going on, even when I probably don't. Select pins for that. Then direct control of operations. Okay, then the third level is objective driven or mode operations. And the things I want to do are, I want to timed dispensing of PCBs. That is where I put a series of boards on the conveyor and it spits one off every X interval. I want to do ingest a PCB and oh, that's right. So I need to check, where are we? Direct control of operations, PCB sensors, to do speed control, back up here. I want to do ready in detection, and I want to do ready out control. Okie dokie. Then ingest PCB and ingest PCB to known to exit position, or ingest PCB to mid position. Two things I might want to tell it to do. Yeah, Don S says interface with other machines. Yes, that is definitely it. So direct control of operations. What else do I need as direct control? I think moving, so the distinction I'm making here, I haven't really explained my method of thinking. What I'm thinking about here is a sequence of 3 distinct stages. The first stage is at the lowest level. I want the controller to be able to read from sensors like the PCB sensors and control peripherals like drive the motors. Those are the fundamental building blocks that this device has to do. Then the second stage is controlling those operations directly, and this is where it's operating blindly, sending something like a G28 command to tell it to home itself, sending it a G whatever, it'll
Scott
be a
Miller
G0.
said, need panic stop.
Panic stop. Ooh, okay. That is a very good point. Panic stop. To do. Let's add it in here. Panic stop. Yep. So direct operations are when you're just telling it to do something and it does it. Like move left, move right. In this case, we're not caring about whether the sensors detect anything. All we're doing is telling it to go and it'll just move. So this gives us direct control over the different parts of the conveyor. We just directly tell it to move to a certain width. Like we can tell it to home, we can tell it to move to a set width. Now the thing is that later what we want are more safety interlocks. For example, if the conveyor knows that there is a board loaded on it because it's triggered one of the sensors or whatever, so it's sitting there in a state where there is a board loaded, it should refuse to move. Like in terms of its width, it should refuse to home or set its width in any way, because it's either going to try to crush the PCB if it reduces its width, or if it goes wider, it's going to drop the PCB. So that would be bad. But in the direct control of operations, we're not caring about any of that. What we're doing is making the software building blocks or the command building blocks that allow the thing to do the different things. And then the third level is the objective driven or mode of a mode operation. So that would be in the situation of loading boards to feed them into the reflow oven. You might have 3 PCBs sitting on the conveyor and you want to spit them out one at a time at a defined interval. So I might want to put it into a mode where it's going to do timed dispensing of PCBs. Or actually, another variant of that would be dispensing of PCBs triggered by ready in from next machine. So that would be a situation where we've got a number of boards that have been pasted and they are sitting on the conveyor and they're ready to be fed into the pick and place machine. So when the pick and place machine asserts its ready in signal and says, I am ready for a new board, we need to detect that and then spit one board out and bring the next one up to the exit ready to go. So we need to be able to ingest a PCB to a fixed position, ingest a PCB to the mid position. These are for the inspection mode. This is for in fact I'll write it here to make it really clear, for feeding boards to reflow, and this is for feeding boards to PNP. So it's two different use cases there. One's on the output side of the production line, so it's going to the reflow, and the other's on the input side of the machine. And when we have an inspection mode, which is between, say, the output of the last pick and place machine and the input to the reflow, we need to be able to ingest a PCB, bring it to the middle, and then just pause there until a command is given to say, yes, this is ready, it can proceed to the next stage. So this is all about state machine level stuff. Jordan, you're here. Briefly at least. Hey. So, where are we? Oh, there are a whole lot of people who have joined the chat who I haven't acknowledged. They've ended up in the chat list. So we've got Dentistries, Espro, Cable Tie, Pete. Some of you I have said hello to. Keith H, welcome. DIY in the Ghetto, Guildco, Fazla, Jax Tech, Johnny Bergdahl, Alicia, Kai AH, Joe Gold, David C, Jordan Reese. Welcome.
Tabraze Malik said, should you also need a ready out from previous machine?
Yes, that is going to be involved in the ingest part of the process. If this is sitting on the output side of a pick and place machine, the pick and place needs to be able to assert its ready out, and this needs to detect it and assert its ready in, which goes to the back to the pick and place. So the two basically say, the pick and place says, actually left and right, so I'll reverse it. The pick and place says, yes, I have a board ready to send you, and the conveyor says, I am clear, I'm ready to accept a board, and they both say thumbs up, therefore they both run their conveyors at the same time, and the PCB moves along from the conveyor of one to the conveyor of the next. So that comes into the ready in, ready out stuff. And because I designed these conveyors to be able to run in, this conveyor controller can run in either direction. It can run in either left to right mode, or it can run in right to left mode. I put in ready in and ready out connections on both sides. You don't actually need them on both sides. You just need, yeah, you can do it just with, or do you? Anyway, doesn't matter. Yeah, actually, I think you do. You do need them both sides because the machines have to handshake in both directions. It's ready and no, ready and no, you can get by with just one, but yeah, one on each side. All right, so then, where are we? We've got 10 minutes left. I'm going to try hooking up the stepper motor controller and see if we can make this thing do a homing sequence, just to validate that it still works. Well,
Scott Miller said, for the ingest send to reflow, will you base board position just on the outfeed side to allow you to fully load up the conveyor?
That is an excellent question. I've got to figure this out. This is going to be a little bit of experimenting with how this works, because what I could do is, okay, so to clarify Scott's question, if I understand correctly, what Scott is asking is, on what basis do we ingest boards and how do we space them? So one way this system could work is, when you feed a board in on the input side, it knows based on that input sensor when the board has started getting onto the conveyor. And then once it clears that sensor, it knows the board is fully on the conveyor, and it could then run for another, however long it is, to create a nice little interval. And then when the next, Sion says, this is a really bad idea. One board at a time waiting. Yeah, this may be a life decision that I regret. And then...
Unexpected Maker said, ask me how I know.
Yep. And then the next one, when it is ready to come on, could move on. So you got the two boards moving along the conveyor with a space in between them. And then when a board gets to the end point and it detects it on the exit sensor, the conveyor knows that it's full and it can't accept any more. So yes, all sorts of logical things that can go wrong there. Certainly in the short term, I concur with Sion, and I don't want to overcomplicate it. So let's hook up. Where are we? It comes home Y-axis. Okay, so let's hook up the stepper motor and see if that turns, because that would be kind of cool if we could get that going in this stream. Where is the stepper motor header? Here we go. Okay, stepper interface. So we've got 1, 2, 3, 4, and then we've got the 5 volts and ground. What do I have? So I need to solder up a header. 1, 2, 3, 4, and then 5 volts and ground. I need to solder up some wires to this and to a couple more. Let's get out. I'll get out some headers. All right, now everybody remember that picture, this header, because I am about to switch to this view. That header. Oh, this is a real stretch. How am I going to do this? Okay, so that white header under there that you can just barely see, it's awkward from this camera view because I've got everything plugged in. USB going that way, I've got stuff going this way, I've got the scope plugged in here. So that is the Y-axis stepper header. That is the 5, it's the 4 pins that go to here, plus ground and 5 volts. So I'm going to remove this. This was from some previous experiments I was doing. Looks like a ground connection. Get rid of that. And I need to make up a little cable that will go from this to that. And 1, 2, 3, 4, 5, 6. So I need to drop one of these. And I think, 2 fell out, of course. I do actually have six-way plugs here somewhere, but rather than opening the box to get them out, I'm going to trim something down from a larger size. Okay, so 3, 4, 5, 6, and that. Yeah. This is an annoying part of any of these jobs. Oh, doesn't really fit properly. All right, got to do some trimming. Yeah, I know, I've stopped talking. My brain has faded temporarily. And what I should be doing, I know, is using proper JST connectors. But as I said, I hate wiring them up. I hate doing the little crimps. They suck. All right, that'll fit now. And then I need, well, actually this works out okay. So I need a a two-way header and a four-way header to go onto the motor driver board. So now I've got my six-way that goes into the controller, a two-way, and then I'll turn this into a four-way, which can go to in 1 through 4. Boop. And then I just need a bit of wire. There, what a mess. Bit of wire. Although I am super tempted to just munge some. Will I? Won't I? I think I will. I think I will. I'm going to grab some jumpers and just hack them. So what do I want? That maybe red and brown, and then the other rainbow colors next to it would be a good combo. Oh, there's a shorter one. Do I want shorter or longer? I think I want longer. All right.
Pete said food.
Yes. food. So we've got negative, positive, and then we've got those 4 ins. So I'll do red, brown. Or maybe if I go that way, then I get 1, 2, 3, 4 minus the blue. Yeah, that works. So I'll split it here. Then I've got 2. Black is not going to be ground, unfortunately, but that's just the way it goes. And then we've got that. I'll take off that. And that's it, I think. So now what I should be able to do is plug these jumpers in. Are these going to fit? I think they will. I think they will. So what I should be able to do is plug these into the header. Oh, it's happened. Who did it? Who was it? Pete. Pete. Pete is now a member. Yeah, also, okay, so I need to figure out which way, I'm just going to switch back to this view for a moment, which way around. What? Another one? I've lost the chat. I actually can't see where it is. Where is the chat? There it is. So Pete is now Silver supporter and a member for 23 months. Thank you, Pete. So orientation, so ground is at the top. That is in 1. Okay, so the connector is kind of upside down from my perspective. Ground at the end. So I need to swap red and brown so that 5 volts is the second one down. And then get this into here. I might need to disconnect things. In fact, I'm going to disconnect the scope. That's just going to get in the way. And yeah, I'll disconnect another one. Who is it this time? Who is it? Johnny. Member for 29 months. Yes, my hot Swedish friend. Johnny, thank you for being a member for 29 months. Can I get this into here? Will it fit? This is total butchery for an XH connector. It feels like these pins are not engaging properly. Or is it just that I'm not pushing it in properly? Okay, let's... I'm going to disconnect, power down, disconnect that. In fact, let's get those off as well, just for now. Just while I try to get this all hooked up. Move that out of the way. Now what I need is ground and then 5 volts. So those two into there. He started a run on it. Henrik! Thanks, Henrik. You fell asleep a few times. Well, that's not really surprising given the time zone difference. Tassie Bob! Tassie.
Breakfast time. Bye.
Breakfast time. All right. It's a dodgy connection, but we do have a cable in place there. Now, I need... So that's in 1 at the bottom. So purple is in 1. Tassie Bob for 28 months. Nearly there. Yep. TTS has been busy the last few minutes. What? I figured it out. I don't even know how to do a cable tie. I don't even know how to do it. I'm glad you figured it out. Hi Tassie Bob, bye Tassie Bob.
Pete said, hi Tassie Boob, bye Tassie Boob.
Tassie Boob? Tassie Boob or Tassie Bob? Okay, so that is ground. That is 5 volts. And then purple is in 1, which is at that end. Okay, so that folds around that way and goes into those 4 pins. Now this needs a proper cable to do it. And ideally a better way of mounting this PCB. Where are we? There, okay.
Tassie Bob said, no more burgers for you Uncle Pete. Alexa, what's in the news?
Let's set your preferred news channel. You can choose from sources like news.com.au, ABC News, Sky News Australia, and Listener News. What would you like to hear?
ABC News.
From ABC News, here are the latest stories. ABC News.
No!
Josephine Asher with the top stories.
Let's stop this now. Alexa, stop. Who was it that did that? So it was Henrik. Good job, Henrik, working around the protection. Okay, so we've got the motor driver connected. I'm going to plug these limit sensors, not limit sensors, no, before I do that, I'm going to plug this in. Okay, let's get back to the documentation. Let's RTFM, or let's read the Fine Lab notebook and figure out what the connections were on that Y limit sensor. Here we go, okay. So I actually drew what the markings are on the cable, because this cable has little X's, and then it's got long dashes, and then it's got something written on it. So V plus.
Alexa, turn off the lights.
A few things share the name lights. Which one did you want?
Alexa, stop. I really need to hit that mute button. Now, I know it may be tempting, but do not do the thing that is going to turn off my workbench, because I'm kind of using this stuff right now. So I need to plug this in. So the one labeled the little X's is ground, which is that one. So that goes to ground, and then SIG is the long dashes, and that one goes there. So I've got to swap those two over and plug it in here. All right, so this is for the limit sensor on the back of the chassis. Now, obviously, this is not actually going to move because there's no belt.
Henrik Ostrov said, sorry, it wasn't me this time.
Yeah, it's all right. So, where is it? Left, L, this one. goes there, then middle, and then right, and then I think that's it. I'll just turn off the lab supply before I plug it in. What we should be able to do now is, where is it? Positive, negative. Yep, that's right. And then I'll plug USB in.
Outside the box said, this is the last episode she will function, so we need to hammer it.
Yeah, true. I really don't want to turn it off. Okay, so that is booting. I'm going to grab another little bit of blue tack and put it, it's very hard to see because it's black on black. Just like disaster zone. So I'm going to, or is it disaster area? Disaster zone. So I'm going to put a bit of blue tack on there to make the spindle visible on the stepper motor. And then, oh, you can't see it, but hang on, I'm going to see if I can turn this around. The, get that out of the way. Oh, everything's falling off. The Y-axis limit sensor is powered up.
Alexa, play Crab Ray.
Look at this.
Crab Ray and similar songs on Amazon Music.
You bastards. So the limit sensor, you can see, is powered up.
Outside the box said, yes, disaster area.
Disaster area. And you can see that if I put something in between there, the LED turns off. And that is when the beam has been broken. So it's detected the back rail is at its rear position. So I'm going to move that out of range, out of view right now, just because I need to put this back down again. But what I'm probably going to do, hang on, I'm going to stop that or I'm going to get copyright striked. Alexa, stop. But what I'm going to do is try to get this to home, and it is going to try to turn the stepper. In fact, I'll turn that power on. It is going to try to turn the stepper until the rail hits that limit switch. So I'm going to manually just put a thing in there to activate the limit switch, and that should then make this stop. So let's get back to here, and
Henrik Ostrov said,
here.
nice led to see the sensor working.
Yeah. So what I'm going to do is just do G28. I'm going to switch between the views here. Let's see what happens. It's running. Check this out. Look at this. Look at this. The stepper is turning. And now what I'm going to do is interrupt that, that sensor. And it stopped. So now it thinks it's in its homed position. So if I do a command like, okay, what I'm going to do is send a command like G0. So this is go on the Y-axis, and I want to set it so that the PCB width, like the conveyor width, is 100 millimeters. So what it should now do is try to move the rail forward until it stops at the 100 millimeter point. So I'm going to hit go on this, and then I'm going to switch the camera view, and we'll watch it turn, and then it should stop after a certain period of time. So that's going. Oh, it's calculated steps to move. So you can see that it is now running this back in the opposite direction. So it'll be moving the back of the conveyor forward until it gets to where it's calculated the position should be based on the number of steps, and then it should stop. There it goes. It stopped. Okay, so we now have functional homing on the Y-axis. It's not, there's no belt on it, so it's not moving anything, but it is functioning. And we can send it to known distances. So that is all working. Why did those LEDs flicker? Maybe it's just because I was touching it. Yeah, okay. Oh, it's because these cables were falling out. Because I've just got dodgy jumpers in there. All right, so what I need to do is put a connector on here, and then I can
Henrik
plug in.
Said, also the Crab Rave, if incorrect, is song that won't get you copyright. Linus Tech Tips uses it all the times in her videos, for example, testing speakers.
Oh, okay. I didn't know that. The Crab Rave. I didn't know if if I've even heard of that before. Okay, we have homing. We have the homing limit sensor working. We've got PCB sensors working. We've got the motor running but not calibrated, so I've got to fix that. As in this motor. So this motor runs. So now what I could do is stick that there. All right, I am going to do a couple of things. I'm going to come back to here and I'm going to clear this. So what I can do is the full sequence would be a G28 to home. All right, so it is now homing started. I'm going to stick a ruler into the sensor. So there it has now done homing complete. And then we can say G0Y 150 to set the conveyor width to 150 millimeters. And as you can see, it's currently turning until it gets to 150 millimeters and it stops, should stop at a certain point. Come on, there we go, it stopped. Okay, so then we would be able to do a G0, no, I want to do an M3 S900, which is to make the conveyor move to the right, I think that's left to right movement, at 900 millimeters per minute, although of course this is totally uncalibrated. So I'm going to hit enter on that. And it's not working. Oh, do I even have it plugged in? No, I don't have it plugged in. That's why that's not working. All right, let's see if I can plug this in without disturbing all the other wires. And then we should see that turn. So positive that way, ground that way, front motor, front. Oh, that's right. I didn't have the main power turned on, which was isolating. So it was powering off off USB, but not powering off. Let's make that more reasonable. 1300. Yeah. Okay. You could put just other than 00 in the last two to vary PWM. Ah.
Scott Miller said, you could put digits other than 00 in the last two to vary PWM.
Yeah, but what I want to do is do some motor tuning now. So that, step one, I need to make sure I've actually got the correct motor. I need to put a 120 RPM. Hang on, I'm going to stop this now. So if I do an M5, it should stop. Yep, you would have heard it stop. So it is in fact just overflowing. Yeah, the value is not making sense. What I need to do is make sure I have the correct motor. Because if I don't have the correct motor in there, then no amount of tuning is going to fix this. So I need a 120 RPM 12 volt motor in it. And then I can fix this and be able to give it a speed, and the actual PWM frequency should be fixed. So we've got here, so 5 kilohertz PWM, that should be fine. So we'll do PWM to move it, but I just need to do that calibration, and I will need to do that by measuring it. So what I would do is have the actual, have the belt on it and a mark on the belt and time how long it takes to move a certain distance, or I could do it by using an RPM sensor to measure rotations of the wheel, and based on the 50.65 or whatever it was ratio, I could then, because of the radius of the drive wheel, I could back calculate from the linear rate of movement based on the radius of that drive wheel, what RPM I need to achieve the correct linear movement, and tune it that way. So either way would work. Yeah, cool. So coming back to here, what have we got? Done. Yes, home. So we have just verified that homing works. Setting a width works. Move left, right, stop works, but without calibration. To do direct control of operations, can you think of anything else that we may want to send it a direct command to do? So I'm talking about a low-level operation, because as far as I can tell, this covers everything that I might want to do as a direct command, regardless of sensors. Scott says, how to tell if someone does more electronics than mechanical? RPM sensor versus tacho. Yeah. Yeah. Jiggle command. What's a jiggle command, Paul? Tell me. What's a jiggle command? Alright, to do. Speed control of Y-axis motor. Ready and ready out detection. PCB sensors are done. What other peripherals are there to do? Homing sensor is done. I'm putting it on there just to make me feel good. It's like, yes, homing sensor, it works. Arduino in dark mode has really helped my eyes. Okay, I don't think Arduino IDE version 1.8 series can do dark mode. I think that's only in the 2 series IDE. Make the board twerk. Scott. Set width both wider and smaller without a previous home. Oh, it does that. So Graham said to do set width both wider and smaller without a previous home. Oh. I get myself confused here because of the firmware for the KO. I have a config option in that firmware. In fact, if I find it, projects, open KO, firmware, open KO. Yeah, I'll show you what I did in that, because conceptually maybe I'd want to do a similar thing. So the OpenKO firmware takes these G-code commands to do different things on the pick and place machine. And that in the config has require homing true. Refuse to move until a homing operation has been completed. And that is because the KO will not allow you to break it, as in it has both min and max position sensors, and if you try to drive it beyond a certain point, the motion controller built into it will refuse to move. So it's safe in that respect, but what I did was set it so that if require homing is true is turned on, if you simply power it up and then you send like a G0 command to tell it to move and you haven't homed, it'll refuse. It just won't even process it. So, but I have that configurable so I can turn it off for testing. But in the case of the conveyor, what it does is it does a home, and then once it's homed, you never need to home it again. Well, until the power cycle. You can tell it to move to different things. And the thing is that on the conveyor, so in the OpenKO, there is all of this. There is also conveyor control stuff in the KO, because of course the pick and place machine has a conveyor belt in it. So we've got G-code commands for things like ingest PCB on the conveyor, exit PCB on the conveyor, run conveyor, stop conveyor, clip PCB, engage. Like you can do all of these things directly by sending these M-code commands on the... In fact, what I should
Scott Miller
do...
said, is there a sensor for 0 on the board width stepper?
On the board width stepper, yes, there is. There is the sensor... Well, no, there's a sensor for fully open, and then it counts steps from there to move to a position. But there is here a minimum conveyor position. So what happens is that if you home it, width to 0 based on the homed position. So what I do is I configure the offset, and this is when you tell it to home, it moves the conveyor back until it triggers that limit sensor, and then it offsets by, it then steps 100 back again. So it backs off the limit by 100 steps, which is a very small movement. It's 100 steps of the stepper motor, which is geared down. So 100 steps is a tiny movement. And then at that point, it knows that it is 296 millimeters wide. So if you told it to go to 196 millimeters, it would move 100 millimeters forward. It's always offset relative to that zeroed position. And it will never try to go less than 45 millimeters wide, because then the motors hit each other and stuff. There's no reason to. Maximum conveyor position is greater than this, but if you try, it'll hit the limit sensor anyway. Might be bad if something glitches. Is there a sensor for 0 on the board width stepper? Yeah, so I know what you mean. So at the moment what it's working on is a sensor for the maximum open position, but there is no sensor for the minimum closed position. I could potentially add another sensor for that so that it zeros by moving in instead of zeros by moving out. But yeah, we'll see if it's necessary. I have a feeling it won't. Alright, PCB conveyor. Yeah, hard limits, says Don S. Yeah. Who wrote the song they use in theme intro? Okay. Sorry, I was just looking at the music copyright stuff in the chat at the same time. Now, what I should probably do is maybe reuse some of these G-code commands. Some like pin engage conveyor, clip PCB conveyor, they don't matter. Run and stop. I've used M24 and M25, but I've got different ones on this conveyor. But what I could do is I could use these for setting the
Scott Miller said,
yeah, it doesn't
might
really
be
matter.
worth installing a micro switch that just stops the stepper.
That's an interesting idea as an oh shit sensor, basically. So run the normally closed pins through the run power to the stepper through the normally closed pins on a limit switch on the low side, so that if everything fails and it tries to crash the conveyor closed, it'll hit the switch, which will kill power to the stepper. And of course, at that point, it would have no idea where it is, so you'd have to rehome it. And in fact, you'd physically have to push it off because there'd be no power to the stepper. But at that point, it's just saving itself anyway, so you don't really care. You know you're in a bad state if it's got into the point where it's tripped that lower sensor. Scott, that is an interesting idea. I'm going to add that as... oh, that's not in OpenKO. I'm going to add it in here as a potential future improvement sort of thing. I'm going to say
Scott Miller
power
said,
stepper.
make a note. Save yourself the headache.
Yeah. Stepper power through limit switch in fully closed position. Limit switch at front position. I'm trying to figure out how to word it so that this will make sense when I read it next time. Power to stepper through NC pins of limit switch at front position to prevent close collisions. Something like that. I think that makes sense.
Scott Miller said, "Dang TTS delay."
Yeah. That's a bootstrap. If it opens a switch, you can't drive it off. Yes, that's right. So I'd have to physically push it, which would make the conveyor, make the stepper spin. And at that point, you'd probably have powered it down anyway to figure out what the hell is going on and solve the problem. All right, select pins for PCB sensors. No, that doesn't need to be done because that is already done. Select pins for H-bridge motor control. That is already done. Select pins for ready, in, out for left and right. That is already done. So, yeah. Okay. One thing I need to do is finish physically manipulating, physically assembling the conveyor. So I need to put the linear rails on. I need to and bolt on the rear rail, put the motors in place, put the actual conveyor belts in place, and then physically it would be 100% assembled. At that point it is just a software thing. Oh, and I also need to design a housing for this because I need to mount this on the front. At the moment this is okay for just rough testing, but I've got to put this actually mounted on the front to make it all neat so I can just pick it up and move it around. This is not practical long term. So I need to make a design and print an enclosure for it.
Outside the box said, could a soft mechanical bumper be used to push it back as the power goes off, so it can repower itself, but still throw a fault?
Potentially. I know what you're saying, but basically it would end up bouncing off that if it continued trying to move, unless it detected it and then and stopped trying to move the stepper. Yeah, I don't know. To me, at this point, that all of this feels a little bit like premature optimization. It's like trying to solve a problem that we haven't seen yet. I understand anticipating that this could be a problem, but this stepper is not super strong. So worst case, if it went out of control and it lost its position and it was closing the conveyor, so moving the back rail towards the front, and it overshot and it basically jammed into this, what would happen is the stepper would probably just start skipping on this little drive gear. So the belt goes around that. They're over the other side of the room, so I won't bother getting one now. The belt goes around this little drive wheel on the stepper, and that, you can see it's flopping around at the moment. That's because it's an adjustable tension. There are slots here in the enclosure. So what I do is I drop the belt on and then slide this forward and then do up these bolts, and that just puts the tension on that drive belt. But the drive belt would end up just skipping on this and no permanent damage would be done. Worst case, maybe you got to replace the belt or something if it tore it up.
Add a breakable joint in the belt or slipping.
Yeah, all of these things could be done, but I just don't think they're necessary. Because I think slipping on this will save it. So, yeah, doesn't matter. I understand that having it crash into the front is a potential problem because it's open loop at that point. It homes and then it goes open loop and it just counts steps to move to whatever the target position is. But as long as it keeps track of the target position, it doesn't forget it, and you don't miss steps, so the stepper never actually skips, it should be able to go to a known position and not overshoot and close too far, because I've got that 45mm limit. If you ask it to do anything less than 45mm, it'll just refuse to do it. So it'll always maintain a 45mm gap at least at the front, which I figure is the smallest I'd ever want to it to be for running tiny PCBs on. So, while still allowing clearance on motors and things. So I think that is trying to solve a problem before discovering that the problem exists. So let's put that aside. Okay, and then this wire, which I have not yet connected.
Said, can it crash to the other side?
No, it can't, because it'll engage the limit switch. If you have it driving towards the back and it hits the limit switch, it stops. Mind you, that is a software thing, because the software is detecting the limit switch. If the controller was ignoring the limit switch, so this is the limit switch wire here, if the software was ignoring the limit switch, it would just keep trying to drive backwards and it would crash into the back. But this is not a super strong stepper. It's just one of these cheap little 28 JBY, whatever they are, I can't remember the part number, steppers. It's not going to kill anything. This is not like, and the thing is that when it's moving, it's only like, it's not like a pick and place machine with lots of power that flies around. It moves slowly. It doesn't have a whole lot of force behind it. You move it once when you're setting up a job, it doesn't move again. It just stays there for the rest of the job. So yeah, as I said, I think this is all trying to protect and optimize from something that is not really a problem. In worst case scenario, it crashes, the stepper skips, well, deal with it then. So I need to put proper connectors on these, and the other end of this wire, so this wire here that we've connected, this goes to this motor, which is for the front belt. It goes onto this rail. There is another motor.
Scott Miller said, if anything, the stepper might cook itself.
Yeah, maybe. But it's a $4 stepper, so I don't really care. And the other motor that faces the other way for the rear belt, this is the wire that goes to it. So I need to hook that up. This is it here coming out. And I've got a little drag chain that bolts on. You can just see there some holes in the frame. I need to bolt the drag chain on there, and it comes up here and loops around onto the rail. So I think I'm going to continue with this afternoon. I'm now over time. I'm going to stop. Yeah, Henrik is talking about food again. I'm going to stop because I need a rest. I need a brain rest, and I need a stomach rest. I need to eat and drink and be merry. And then I'm going to hook the rest of this up, mount the rails, and by the end of the day, mechanically, I should have this 100% functional. It's then just a matter of fixing the speed calibration thing on the DC motor, and I'll be able to actually make it do some useful things. And at that point, it's a software problem. So it's easy. Once it's in the realm of software, it's no problem at all. So, Scott said, we'll remind you about the $4 stepper when you don't have a replacement in stock. That's right. Yeah, I have that philosophy where it doesn't matter how cheap a part is.
Alexa set a reminder for Johnny to eat lunch.
Who did you want me to remind?
Jonathan.
When should I remind you?
In 10 minutes.
Okay, I'll remind you in 10 minutes.
Okay. Henrik, that was well done. That was clever. So you also totally threw me. What the hell was I doing? What was I talking about? I don't know. I really don't know.
Outside the box said, go eat and be merry.
Yeah, go eat and be merry. It's normal a belt there was... Yes, that's right, that's right. I remember now. That thing about a resistor, like a little surface mount resistor, may be worth 0.006 cents, but if you don't have any and you need one, its value is suddenly very, very high. So yes, you are right, Scott, when you said we'll remind you about the $4 stepper when you don't have a replacement in stock. Yeah, it's more important to have it than to not have it. Failure, F Mika. So Don S is getting very formal here. Failure mode effects and criticality analysis. F Mika. All right. That is. Oh, hang on. I'm going to say hello to a couple more people. Henrik, I've already been talking to. Oracle has joined the chat. Aaron Knox. Aaron. Andrew Gordon is here. Stephen George is here. Greg Lane. Graham Brown. So I'm going to go. All right. This is my undertaking to you. By the end of today, I am going to have all of the mechanicals assembled for this so that I can send it the low-level commands and make it home, make it turn, etc. to the point where everything else that needs to be done is done in software, so that I'm no longer messing around with wires and things.
Henrik Ostrov said, I think you talked about juicy grilled chicken in tomato sauce.
I didn't, but you probably did. Okay, so I'm going to go, and thank you very much for hanging around with me on this conveyor belt journey. And I will talk to you all really soon. Okay, thanks. See ya.